So my co-founders and I had recognized some time ago that we faced a real challenge around both the cost and sustainability of battery technologies, so electrochemical battery technologies, when it came to storing many hours of renewable energy. So batteries are great for short bursts of power, but we identified a need for different technologies to deliver sustained power for many hours at a time. So the concept for our technology came from many years of research, and we saw the opportunity to do something really exciting with it to solve a massive problem. We've developed this energy storage system, which we call Etanker, that stores electricity in the form of heat and compressed air. Now, when there's surplus electricity from the grid or from renewables, even better, we use electric motors to drive air compressors, and that converts electricity into heat and compressed air. What's a bit different is that we make those air compressors from ex-service truck engines. We take an ex-service truck engine and form a diesel engine and use an electric motor to drive that. We don't burn anything, but we use the pistons to compress the air. Now, we store the heat in tanks full of gravel, and we store the pressurized air in steel tanks. What that means is that we've got a really low cost solution that is also very, very green. So the main raw materials are gravel, air, and steel, which means it's really sustainable. It's very, very widely available. It can be manufactured anywhere, and really avoids any kind of rare or toxic materials. We can use this energy storage system in a wide range of applications. One of the really interesting ones is to help support electric vehicle charging. So when a distribution center or a depot wants to move their fleet of commercial vehicles to electric vans or even buses, we can use the energy storage system to help provide that energy. Now, that's really interesting if the site doesn't have a big grid connection. So if the grid connection is limited, then it's difficult to get enough electricity in to charge that fleet overnight, for example. Now, we can use our system to act as a buffer. So we can store up energy from solar or from the grid during the day, and then make that electricity available overnight to charge the vehicles so that they're ready to go in the morning, as we would expect. I've really always been interested in climate change, and obviously it's a huge challenge, one of the biggest that we face as a species. But as an engineer, it was fantastic to realize that actually a lot of the skills and kind of learning that I've kind of been lucky enough to kind of develop is absolutely kind of really relevant and kind of directly relevant to help addressing that and tackling it head on. And it's really, really exciting and rewarding to be part of a company and started a company that is able to attack this in a direct way and really make what all of us care about so much be the focus of our professional lives. And that makes being in clean tech and being in sustainability just a fantastic and really, really rewarding place to work. We're really excited to be exhibiting at the Distributed Energy Show. We'll be sharing videos and models of our technology and even some of our hardware, helping to explain what goes on inside our system, as well as how it can really help to enable decarbonisation and kind of support our customers with clean energy operations, and help them to move to a low carbon kind of systems with minimum hassle, minimum disruption, and minimum cost. So yeah, we'd love to talk to any and all partners, suppliers, customers, everyone. The name Cheesecake Energy wasn't produced by our marketing team. We didn't have a marketing team when we started the company. It was all engineers. The story behind it is very technical. We actually started with two technologies which we brought together. Both of them had acronyms, as we are engineers after all. So those two acronyms, one was GIES and the second was CAES. So we put them together and we got Cheesecake. That was our acronym for our new technology. But very quickly we realized that no, it can't be our technology. We have to be Cheesecake, and we still are.